So in this case, we are going to consider this part as a continuation, looking into questions where the function multiplied to its derivative can be greater than 0, can be greater than or equal to, we can have less than 0, you can have less than or equal to 0. Or a certain function multiplied to the derivative of another function. Take note, this is f of x, this is its derivative. But here we have got f of x, a different function, a different derivative, which can also be greater than 0. It can be less than 0. It can be greater than or equal to, it can be less than or equal to. So the question is, how can we answer these typical questions? So if you consider this one, it's a combination of what we have referred to before. Before we had this condition, if you still remember, we had a condition where f of x was multiplied to gx, then it's greater than 0. Then I said, when it is like this, you are going to consider the x-intercepts. That is the major part of your critical values. It will be the x-intercepts so that you can tell what is above of the x-axis to be positive, what is below to be negative. There was no derivative there. This time there is a derivative. So our critical values are also affected by the derivative part. Remember, in our previous class, I mentioned the derivative f of x being greater than 0 or less than whatever that you're given. The derivative, where I say the most important thing will be the turning point. For a graph that has a turning point, you consider the critical values as the x value at the turning point, as we are to consider the turning point. Remember, going up to the turning point like this, it's an increase, so it'll be positive. Going down, it'll be negative due to the steepness of the slope of the given line that you're given. Positive going up, negative going down. So it becomes a critical value to be considered, which is the x value at the turning point. But f of x is a function on its own without the derivative. When we are comparing f of x to values that are greater than 0 or to values that are equal to 0, what we consider, it will be the x-intercepts. The x-intercepts. When it is the first derivative, the turning point. Whereas if you are given a hyperbola, remember a hyperbola has got its own properties. You consider what? The asymptotes, which is the x value for the what? For the asymptotes. So this is the combination that we are going to use, guys. We are going to apply this combination to find the exact solutions. So we are going to have critical values for the original function that you are given. For the original function, your f of x, it can be gx, it can be hx, whatever that you're given as your original function. Whenever you are to consider the critical values, it is the intercepts, x-intercepts. The intercept with what? The x-axis. X-intercept. When we have a hyperbola on that case, we consider what? The asymptotes. So we can have x-intercepts, we can have what? Asymptotes also to be considered where there's a graph that has got what? Asymptotes. But for the first derivative, our critical values will be taken at the turning points now. That is where you consider the x value at the turning point. But not forgetting if it is a hyperbola, whatever that you have that has got asymptotes, asymptotes also has to be what? To be put into place. But the major part of our critical value, it is what? The turning point. So this is it. Once you know your critical values, now you can have the solution, because the solutions will be direct to say the product of these two, it can be a condition where the product of the two is what? Is less than 0. What simply means this can be positive, this can be negative. This can be negative, this can be positive. Remember the product concept to get a negative. When it is greater than 0 like this, it's either you're multiplying a product of a positive to positive, a negative to a negative. We talked about that before. That idea is not going to change. But what is important is where to find the critical value. So I'm going to answer this question using typical questions, because already we mentioned about these before. So we're not going to waste time. Let's consider a question like this, where we have got a function here. It is given two functions, the one for g and the one for h. But if you check our question, it is to determine the value of values of x for which the first derivative of g times gx is greater than what? 0. And thus we are considering, or we are focusing only on one function, g. It is not affecting h. So we're just focusing on what? On g. This is our gx, which is what? Which is a quadratic, a parabola like that. So if we are to consider, like I said, there we are going to need for the original function, the x-intercepts, because we do not have asymptotes for a parabola. So you consider what? The x-intercepts, which is the value of x at A and the value of x at B. So in our case, the value of x at A was -1. At B, it was +3. And the value of x at the turning point, it was corresponding to 1. At the turning point, the value of x was corresponding to 1. All right, so those are the most important. So considering f of x, we are going to indicate our critical values where at the x-intercepts, meaning to say we are going to consider on our gx, the x-intercept, which is at what? -1. So that is our critical value. All right. And also at B, which is what? Which is also the x-intercept. That's another critical value that you are going to work with. So these are the critical values for gx, the original function. But the derivative now, when it is the derivative, remember the critical values will be the turning point. It is measured from the turning point where there's a turning point. So in our case, there is our turning point, which was corresponding to 1 according to this question. It was corresponding to the value of x when it is 1. This is the condition of our turning point. So we have got all the critical values. So as you can see, our graph is now subdivided into 4 regions. The first one, the second one in between -1 and 1, the third one in between 1 and 3, and the fourth one, which is 3 going to that side. So let us measure and see what is happening according to the inequality that we are given, that the first derivative of gx, when multiplied to the original function, it must give us a value greater than 0. What does it mean? It simply means both can be positive. Both can be negative. So if we consider our f of x, our gx can be measured being positive or being negative by looking into the x-axis, as we have got these intercepts. So we look into the x-axis. Where it is above, it is what? Positive. So in the first region, I'm gonna start with this one. Let me indicate gx. I'm gonna start with gx. So as we consider gx at -1, from -1, -2, minus to the left, we can see that our gx is below the x-axis. It is below the x-axis, so that's a negative. All right. From -1 up to 1, the turning point, because the turning point will be used in terms of what? It will be used in terms of the first derivative. But here I'm focusing on gx. So from -1 up to 1, this region, it is positive. Yes, it is continuous positive. From 1 up to 3, our g is what? Positive, is still above the x-axis. Up to the point at b, where x is 3. From that point, we can see that our g is now below the x-axis. So that's a negative. We are talking about g. Let's consider its derivative now, which is g prime x. Remember, being positive is when you are going up, negative when you're going down. So that is how we measure it for the first derivative. So let's consider -1 at -1, as it is part of our effect. It is affecting. All right. We are going up. The graph is going up. -1 up to the turning point, the graph will be going up. So in terms of the first derivative, the graph is going up. So that's a positive. We're talking about the first derivative. It's a positive. All right. To -1, it is still a positive. It's still going up. The graph is still going up. So it is what? It is a positive up to the turning point where the first derivative is equal to 0, the turning point. Then it starts to go down to reduce, being what? A negative. Going down, it is still going down. The function is going down. It's reducing, being what? A negative. This is for the first derivative. So don't confuse the original function from its derivative. The original function, you look into it from the what? X-intercepts. But its derivative, we compare it from what? From the turning point. So from the turning point, as we can see here, up to the turning point, it is going up. So it's positive. Positive. It's positive. From the turning point going down, that's a decrease. The gradient, the steepness of the slope is negative. That's a negative, all right? So make sure that you watch the previous video. That's where I explained about the first derivative, all right? According to the playlist, these videos are in order. So you check the previous class where I explained about the first derivative on its own, not a combination of two like what we're having here, so that you can understand much better. So this is how you answer your question. Once it's like this, it is easier now for you to have the solutions, because you need where it is greater than 0. Guys, is this my presentation? Greater than 0, it must be positive, positive, all right, negative, negative, all right. So this is what we are going to need. The product of the two to be positive, or the product of the two to be what? To be negative. So if we consider this part positive, positive, all right, negative, negative, all right, the region of -1, this side, it's positive, negative. The first derivative is positive, gx is negative. Remember, first derivative is the one in blue, the gx is the one in black. So we do not have a solution there. All right. We move on in between -1 and 1. In between, because 1 is important. It's part of the turning point. It affects the first derivative. So in between -1 and 1, if you check, both are positive. The first derivative is positive. The function on its own is positive. The function is above the x-axis. The first derivative, the function is increasing. It's positive. So this is what we want. So in between -1 and 1, this second region, there's a solution. All right. The third region, we can see 1 is negative. The first derivative going down is negative. Well, the function is positive. So its product cannot satisfy what we need. So it is wrong. Then the fourth region, if we check, our function is negative. Its derivative is negative. Both are negative. We need that in our solution. So our answer will be taken from the second region and the fourth region. So therefore, we are going to have our solutions as what? So therefore, in between, as we can see, in the second region, it's in between two values, -1 and 1. So you write it this way: x is greater than the smaller value, -1, but less than what? The bigger value, which is 1. We do not have equal to 0, so we're not going to put that one. So this is for the second phase, or this part, which is the last one, the fourth one, compared to 3, these values, they are greater than 3, where both are what? Negative. So x is what? Greater than 3. So this will be the two set of your solutions. This is how we answer our questions. G prime, the first derivative taken from the turning points. The gx, its critical values will be what? The x-intercepts. The x-intercepts. All right, let's consider another part. They can give us something like this. All right, this was this time we are comparing two different things, f prime and gx. All right, so let's see our f of x. Our f of x is a parabola. All right, so okay, that one can be quite easier to work with because we just have to consider the turning point. All right, so this is it. This is our f. All right, then our g, it is the linear function, the straight line. All right, this is our g. So they are saying we must determine the values of x where the first derivative of f times gx is less than or equal to 0, where it is less than or equal to 0. All right, so f prime x, the first derivative, whenever it is used, remember that its critical values for a parabola which is a turning point, its critical values will be the what? Will be the turning point. Gx, it is what? A straight line, a linear function. So its critical values will be the x-intercepts. You work with, the x-intercept. You work with the x-intercept. All right? That is the major case, your x-intercept, where it crosses the x-axis. Remember, f of x, whatever other function, it's x-intercept or asymptotes if they are there. F prime, it is the turning point. That is the issue of what? The critical values. So this is our critical value. So that was, in our case, it was at -2. This value was at -2. At the turning point, the value of x was 2. We are not worried about the x-intercepts of what? Of f. F is not given. We are given its derivative. So we do not work with the x-intercepts. For the first derivative, critical values is what? The turning point. So do not waste your time trying to have solutions from those 0 and b. Never do that. It's a waste of time. All right. So this is it. Here we said our critical values will be what? X-intercept. So everything is there. X-intercept at -2, that's our critical value. We indicate our critical value, all right? That's it. The turning point, at the turning point, that's another critical value at the turning point where x is equal to what? Where x is equal to 2. So with this information, guys, we are done. Let us compare to see what is it that we need to give us a value that is less than 0. F can be negative. I mean, F prime can be negative. This can be positive. This can be positive, this can be negative. So we need a product of such or a such, all right? If we check our G compared at this point of -2, at -2, our G is below the x-axis. So that's being what? That's being a negative. All right, G is being negative. From -2 going up is positive. All right, it's now above the x-axis. So G is positive, as we can see throughout. Now it's above the x-axis. All right, so there's nothing about this G. All right, it's just positive. So let me indicate in blue so that we know this is for what? This is for G. It's positive throughout, just negative at -2. All right. Anyways, let's check what is happening on our F. On our F, remember the concept is that it is its derivative. So we focus with the turning point. At the turning point, going up, as you can see, it's increasing to the turning point from this region. It is not about it is below the x-axis. No. We measure the graph, is it an increase or a decrease? So as you can see from this, guys, the graph is going up. So it's positive, positive, all right? Positive. Up to the turning point where it is equal to 0. At the turning point, the first derivative is equal to 0. Then it starts now to go down. It is reducing. Now a negative. This region is a negative throughout its derivative. This is the idea. So where is it that one is negative, another one is a positive, all right? At -2, all right, if you check the graph, the way that it is drawn now, it will be like there are no values. This graph is still extending, guys. It can even like that. It's still, there are values which can be there like -1, -2. So if you check your F, it is having values there at -2, but it is in the what? It is in the positive. It's an increase. I mean, F prime X, the first derivative is going up. So meaning to say, we have an answer there because it's negative versus what? Positive. Remember, G is negative. We compare at what? At -2 for G, the x-intercept. So meaning to say, therefore, x can be what? Less than -2, -2, and so on. Those values is going to be under a negative. It's going to be under a negative region. So x is less than -2. But there is an equal to there. So it can be less than or equal to. All right. There we do not have anything that can be undefined product like this. All right. So that is it. Let's move on from -2 up to the turning point because it's our critical value, and we've got 3 regions here in between -2 and 2, then from 2 going this side. So we've got 3 regions because of our critical values. Between -2 and 2, we can see that the first derivative is positive and G is positive. From -2, G is on top, it's positive. So these two cannot give us our answer. It's totally wrong because both are positive. We need, when one is positive, another one is negative. So the second region does not satisfy our solution. The third part, from the turning point where x is 2, we can see that the first derivative is now a negative, is going down. So it's a negative, a decrease. Whereas our G is going up, still positive. So this is positive versus negative. So we need that one. So from 2, the critical value at the turning point. So that is another solution. X can be greater than 2. That is, or equal to 2 because of that equal there. All right. So the 2, All right, not equal to 2. Let's, okay. The equal to there cannot be, all right, let's check at 2. At 2, this is corresponding to the turning point. And at the turning point, the first derivative is what? Is a 0. So yes, it can be that like that. It can be also greater than or equal to 2. Okay? We need that part of our turning point. So it can be less than or equal to minus 2, or it can be greater than or equal to 2. Those are the x values. Just like that. So you see, these questions, guys, they're just direct. You just have to study your diagram. Study your diagram. On this one, we have got two things to be compared, for which values of x is f of x times its derivative less than or equal to 0. All right. So we have got f of x. F of x is a parabola. This is our f of x, a hyperbola, sorry. So that's, we have got a hyperbola this time. So this is our f, and it's a hyperbola. So we've got this part here. This is our f. So remember, whenever a hyperbola is included, guys, we refer to the what? The x value of the asymptote, the critical values. F of x, it is the hyperbola. That's the original function as it is, and that's a hyperbola. So the critical values will be the asymptote, the x value on the what? On the asymptote, which is the x value on the asymptote is what? Negative 3. So that's a critical value at minus 3. It is what? A critical value. The asymptote, it separates. All right. What about g prime x, the first derivative of g, as g is given as an exponential function? What will be the critical values? It is also affected with the asymptote, but in our case, we do not have the x asymptote. Remember, the asymptote, when it is to be having an effect, it must be the x value. X is equal to what? So we do not have an effect. We just have to consider where it is it an increase or a decrease? So the first derivative, if we check our g, it is what? An increasing function. So meaning to say, for g, it is a positive throughout. I mean, for g prime x, it is a positive throughout because of what? It is an increasing function. Remember, first derivative, is it increasing or decreasing? This one is increasing function. So meaning to say, it is what? Positive throughout in terms of the first derivative. But as of f, the critical values are the what? The asymptotes. So f is measured by the asymptotes. So we can now consider the x. Also, there's an x-intercept on this one. There's an x-intercept. So it must also be taken for f. F does not have the derivative, is the original function. So you consider asymptotes and what? X-intercept. All right, let me get you back. I want you to understand what I'm saying here. If you are dealing with the original function, all right, this is it. If we are dealing with the original function here, something like this, x-intercept asymptotes. For a hyperbola, it has asymptotes, but also it has x-intercept. So the x-intercept is supposed to be taken again as a what? As a critical value. It is there. We have the x-intercept on what? On there. So we must consider it. So that is it, guys. Once you understand this, you are done. So that's at minus 1 there. We have got what? We have got a critical value. So we are done. Let us now answer our question. Our question here is that, where do we have f of x multiplied to the first derivative of g? Where are we going to have values less than or equal to 0? Where are we going to have negative? So it's going to be positive to negative, negative to what? To positive. So we check if any of these is occurring. All right. So let's start with the critical value. As we can see, our graph, or the whole presentation is now divided into three regions. The first one at this side of -3, in between -3 and -1, the asymptote and the x-intercept. In between, there must be a solution. Then from -1, this of the x-intercept to the other side is another part of our solution. All right. So let's see which one is going to satisfy. Okay. The first part, our f considering or comparing with the x-axis, it is above the x-axis. So that's a positive. This is our x-axis, remember? So our f is what? Positive, above the x-axis. Whereas our g is also positive. Remember I said g is an increasing function. So its derivative, g prime, is positive throughout. So this is positive versus positive, no solution. The second part, let's check what is happening with our f. Our f in the second part from -3 to -1. Our f is found below the x-axis. It is below the x-axis. When it is below, it is a negative. But the g prime, remember g is an increasing function, so the g prime x is what? Positive. So we need that solution, positive and a negative. So this one satisfies what we need. F is negative. It is below the x-axis. But the first derivative of g is what? Positive. It's an increasing function. All right. Then we move on to the last one, -1, going this side. We can see that f is now above the x-axis. It is now a positive. Above the x-axis is now a positive. Whereas g prime is continuously going up. It is a positive. So we have positive versus positive there. No solution. So therefore, our solution was going to be in the second region, in between -3 and what? -1, in between. So x is greater than -3. Can we say equal to -3 because of there is an equal to here on our solution? Can we say it is greater than or equal to -3 because there is an equal to here? No, because -3 is an asymptote. Remember, an asymptote, x cannot be equal to -3, can never be equal to that. So you cannot say x is greater than or equal to -3 because of that asymptote. You judge according to the diagram now, all right? But the same x is what to -1? It is less than -1. Can we say it is less than or equal to? Yes. -1 is not an asymptote. So x can be equal to -1. X cannot be equal to -3. Only -3, the asymptote. But it can be equal to -1. So you now judge your question now according to, you now use the solution according to the question. You check your question, the diagram, the way that it is presented, how values are to be taken. Just like that. So you've got our answer there. This is how we answer questions when we are given the first derivative is considered. It's just issue of going up positive, going down negative. So here it was continuously increasing. So it is positive throughout for the first derivative. All right. Let's consider another question. As we can see, there can be different types of questions. This is how you simply need. All right. On this one, we need to determine the values of x for which f of x to the first derivative of g. So we need the first derivative of what? Of g here to the first derivative of g. All right. So let's see. F of x, if we check our f of x, what is important is to note the two graphs. Our f of x, it is this one. That's a little part of, that's a logarithmic, all right, which is the asymptote as the y-axis. The y-axis is actually the asymptote, meaning to say it is part of the critical value where x is equal to what? Where x is equal to 0. It's also an asymptote, and it is the x-intercepts of what? Of G. Do not worry about that. So as of F, it has an asymptote. So its critical value or critical values, I mean, as of this or F, its critical values will be the asymptote because it has an asymptote, the x, I mean the y-axis, and the x-intercept. The original function, guys, is always x-intercept asymptotes, if they are asymptotes. So this one is there, and also the x-intercept. Those will be our critical values. So that was at what? At point B. This one at point B. B was equivalent to 1. All right, the x value at B. So we have got that one as what? As our critical value at B, where x is what? Where x is 1. All right, this is it. As of G prime, the first derivative of G, as of that one, turning point, if we have a turning point and it's a parabola so that it has a turning point, or asymptotes. So we do not have, remember, first derivative, you work with the turning point for critical values. So the turning point is at A, that is where we had our turning point, and the value of x there at A was equal to 1 over 2. So that was the value of x there. It was 1 over 2. All right. So that is only thing, the turning point. We do not have asymptotes for G prime for this parabola that we have. It is only for what? For f of x. F of x is the one that has asymptotes. But as for G, it is the turning point. We measure it. Its derivative is guided by what? The turning points. So let's answer our question. We're done. As long you can note these critical values, guys, we are done. The rest is just answering the question. So meaning to say, if we check here, the question needs us to attempt where f of x times the first derivative of G is what? Less than or equal to 0, meaning to say when one is positive and another one is what? Negative, or when one is negative and another one is what? Positive. This is the condition that we want. So let's start with f. F is measured from asymptote x is equal to 0 and the x-intercept at B. So from B, if we check here, the f is above the x-axis. It is above the x-axis, so that's being what? That's being a positive. It is above the x-axis. From B going this side, from B1 going this side, f is below the x-axis. That's a negative. That is about our f. Then as for G prime, the first derivative of G, from here up to the turning point at A, it is going up. Remember, we measure with the turning point. Up to the turning point, as you can see, it is going up. An increase, that's a positive. So it is positive throughout up to the turning point. Then from the turning point, that's a decrease. Now it's going down, negative throughout. It is a negative. We are talking about its derivative. It will be negative throughout. Here to be positive throughout. So where do we have positive, negative, or negative, positive? You see that it is happening, right? Let's check. Let's check here. Positive. This one. Our guys. How did I put? How did I put a negative? All right. There's a positive. This one, the blue one. All right. This one, the blue one, the positive here for F. whereas G prime is what? It's negative. All right. Remember that F is positive above the x-axis. This is our F in blue. Our F is the one in blue. It is what? Positive above the x-axis. So in between half, in between these two values, in between half and 1, you are going to notice that F is positive, whereas G prime is what? Negative. The first derivative is going down, negative. So this is the region that we want, positive and negative. So this is it. Then from B, which is at 1 here, we can see that both are negative. We do not want that. So therefore, our solution was going to be taken. X is greater than, we are said in between minus half and 1. So it's greater than half, but less than what? Less than 1. All right. Can we say it is equal to half? All right. Yes, we can say it is equal to half because it's not an asymptote. Half is not an asymptote, so it can be greater than or equal to half. What about 1? 1 is not an asymptote, so yes, it can be less than or equal to 1. So this will be our final solution, where f of x times the derivative of what gx is less than or equal to 0. So this is how we answer these questions. They are critical values. As long as dealing with inequalities, no critical values. Just like we were solving a normal inequality before, you were talking about what? Critical values first. X is equal to this, x is equal to that. Those are the critical values. Then you measure from the critical values. You already have them. Say, all right, in between this, do I have that? In between this, in by checking into, because you are using the graph now, you check, you look into the graph. You look into it, the region that satisfies exactly what you're given. So in case that you've got any other questions along the way that you do not understand, question papers that you do not understand, let us join the membership so that you can be able to ask those questions. I'll be able to attempt those questions whenever I've got time. So make sure, guys, join membership. Let us grow our community section. Let us grow our YouTube section by sharing our videos so that your neighbor, your colleague, your classmate can also benefit from the same information if you are benefiting from it. Right? So that is it, guys. That is it till we meet again.